Good morning, everyone. This week we are going to be starting to work with the infrared sensor and remote. Um, Next week we're going to get that sensor and remote to control an RGB LED, which we're going to set up this week as well. And then eventually we're going to be able to use the IR sensor and remote to control things like servos and other pieces of hardware. So ultimately, the end of next week, you guys should be able to press like the number, start my simulation. Should be able to press like the number 1. Sometimes it takes a little while. And the red light should turn on. Should be able to press the number 2, and the blue light should turn on. And you should be able to press the number 3, and the green light will turn on. So let's first just start talking about getting this all set up and getting the basic code put into here. Okay, so here we are in a new setup here. I've imported an Arduino and a breadboard, and I've connected 5 volts to my 5-volt line and ground to my ground line and set those colors up appropriately. So when we come in here, we want to, instead of just searching basic components, we want to search all of the components. And if we come down here, we can find an IR sensor, which we're going to drop onto our board. We also need to find the IR remote, which is down in the like inputs areas. You also could just in the search bar simply type IR, or maybe it's infrared actually, which IR does stand for infrared light. Okay, so if we type in infrared, we have the IR sensor. We also have the IR remote. Put the IR remote near your sensor. It's not like it needs to be in front like it would usually for like a direct line, but you want to be able to see your Arduino, your breadboard, and your remote all like at the same time. Okay, so as far as your sensor itself is concerned, when we select your pins, you have an output pin, you have a ground pin, and you have a power pin. All right, so the first thing we'll start doing is getting things like ground and power set up. We will set the color of these to be consistent. And then for our input, we need to connect this to a PWM input. Okay, so things like 11, 10, 9, 6, 5, 3, anything with the tilde next to it here with that thing next to it, right? Because PWMs are those. The base code has it set up to go to pin 11, so I'll just start off with pin 11. I also want to change the color of this wire. Typically green would be fine for this, but we're going to set up an RGB LED. So we're going to use green later on. So I'm just going to set this to be like a completely different color. Why don't we choose like purple? Doesn't really matter. Okay, so that's our infrared detector. So we actually need a base code to be able to make this thing work. And I'm uploading that to Classroom. Okay, so you're going to go into Classroom, and just where you're seeing this video, you're also going to see the base code. You can copy and paste that base code from there. I'm going to copy and paste the base code from the demo, the IR receiver demo, which came out of the libraries for Arduino itself. Okay, so again, you're going to find this code in Classroom, and I'm just going to copy and paste this code into there. So when I open up my code, I'm going to paste my code into here. Okay, so a couple of things here. When we go to start a code or start our simulation, notice that the receiver pin is connected right now to pin 11. I also have my pin connected to 11. If you used any one of the other PWM pins, you just need to change that value there. We're also going to open up the serial monitor. So particularly, we need to know what the values for 1, 2, and 3 are, but we can start looking at the values for all sorts of stuff, like the power button for this particular remote. has a hexadecimal value of FD00FF. If we press volume up, it has a hexadecimal value of FD807F. And all of these have different values. And this is how like a typical remote is going to work. A button is going to put out a hexadecimal value. The TV or whatever it is that you're trying to control reads that hexadecimal value, and then it goes to basically an if-else chart and says, well, if the value is this, then I want to turn the volume up or change the channel or do whatever it is that you're trying to do. So we need to know what the values of 1, 2, and 3 are, because they're going to be the ones that we're ultimately going to control. So we're going to find 1, which is FD08F7, 2, and 3. Okay, we want to grab these, but for right now I really only care about 1 because we're just going to do 1 LED today. So this last one here is the value that I'm going to need. So I'm going to stop my simulation so I can continue to work. So let's close up my code. We need to add our RGB LED. Okay, so I'm going to bring my LED in here. Okay, for my cathode here, I'm going to connect this up to my ground bar. And then I need to connect some resistors. Oops, stop simulation. Resistors up. Okay, so I'm going to connect a resistor to here. I'm going to change the resistance of this value to 220 ohms. Make sure to change this from kilo ohms to ohms. It should be, that's not correct. 200 ohms. Yep. Okay. So I can take that, I can copy it, and I can paste it in these spots here. Okay, so I have 200. Oh, I know why these look funny to me, because I'm doing 200 instead of 220. So yeah, technically, I guess that these should be 220, which does make the 2 red bands, which is what I've been looking for. So let's just update that. Okay, so I have 220 ohm resistors there. And I'm going to start wiring these up. Ultimately, we're probably just going to be using digital IOs to control these, but for right now, I'm still going to connect them up to PWM pins. So this first pin is a green pin, so I'm going to leave that as a green wire. The second pin, which I'm going to connect up to a different PWM pin, is a blue pin, so I'm going to change that to be blue, and I know that because I hover over that pin. Then I'll hover over this last pin, and this is red. Which I'm not going to set that as red. I'll set that as a pink because red means 5 volts. Pink is somewhere in between here. So when we look at this, again, notice that these resistors are going over like the center trough, so that this side of the resistor and this side of the resistor are not connected except for through the resistor itself. And then I have these things connected up. So let's run back to code here quick. Okay, so again, we have this code down here. So we're going to start editing and we're going to turn on red. So up top here, why don't we create a couple new integers? Let's just start with red first. We'll say red is set to, and in this case, red is set to 6. And then in setup, because this is an LED, we're going to say pin mode, red is an output. Okay. And then we're going to come down to our code down here. And this if statement, this is the one that's like inputting the results. We have to go within this if statement. So notice that this if statement ends, it starts at this bracket and ends at that bracket. We're going to go inside of this. And we're going to create a new if statement. And we're going to say if results dot value are equal to. And one thing I kind of forgot to mention here, sorry, I'll go back to this, is that by inputting this, we've included a whole library called the IR remote library. if you came up here to like libraries, you can see that like IR remote is one of these libraries. So no, I don't want. So things like IR receiver.decode, that is part of that. Results.value, that's part of the library too. Okay, so if results.value are set to, or equal to rather, two equal signs, and we're going to copy this code here, FD08F7. You can't hit Control C for this for some reason. You can either write it completely, or if you right click on it, you can say copy, but don't just Control C because it doesn't work. If results.value are equal to FD07, then we can go through and do a couple of different things. So there's an error up there, but we'll get to that in a second here. So we're going to say digital write red high. We're going to delay at this case for 1 second, and then we are going to digitally write your red low. Okay, so we have this if statement. So it's saying like, if you're getting this value down here, turn your red light on, wait a second, turn it off. Okay, so we can start our simulation and we can give this a check. So this is the error that I was mentioning before. So remember, this is hexadecimal. And hexadecimal, if we go to, I think I have a website, maybe not. In order to call hexadecimal, first, before a hexadecimal number, we have to put the number 0 and then a lowercase x. 0, x refers to hexadecimal, 0b refers to binary. And so this defines like what type of numbering system we're using. So this OX refers to the fact that we're using a hexadecimal number. So now when we start our simulation, that error message goes away. And I press the number 1, and you got to give it a second. It'll turn the light on. It waits literally like a second or so, and then it turns itself off. So we can press the letter 1 again. Press the letter 1 again. All right, keep saying letter. Press the number 1 again. Okay, and that's it. So this is the entirety of this week's lesson. Next week, we're going to make it so that 2 and 3 get turned on when we press 2 and 3. But for right now, that's all you guys need to do. Get this all wired up. Get red to turn on for 1 second, and then get red to turn off afterwards when you press the number 1. Okay? If you guys have any questions, feel free to email me. A couple quick reminders again. You're going to download this code from Arduino or from Classroom. Your receiver pin is where your output of your receiver is connected to. That has to be a PWM pin, okay, such as 11. Your RGB LED ground your cathode is connected to ground. All the rest are connected to a PWM port as well. Set red to whatever value you're using, connecting your red LED to. Set your red LED as an output, and set up your if results.value are equal to, and don't forget to include the 0x. A lot of times people refer to that as like OX, but it's really 0x, and then put the value in for what 1 is equal to. All right. Great job, everybody. We will talk to you next week.